Yeah, so moving on to ways to improve the indoor air quality. The common causes of indoor air quality, the bad indoor air quality can be reduced at source. Like probably we can use less quantities of products which release VOCs, and maybe limit the dust ingress to some extent. Or but that has a very limited effect. And next option is to have good ventilation. So if too little outdoor air enters home, pollutants can accumulate to levels that can cause health and comfort problems. So and sometimes weather conditions also can drastically reduce the outdoor air that enters a home. So the pollutants can build up even in homes that are like normally considered to be well ventilated in cases of such bad weather conditions. So though ventilation is an option, there are certain conditions where we still that also wouldn't really help in reducing the concentration of pollutants in the indoor air. The image here depicts, like for example, in an air conditioned room, ventilation would be less, but nowadays there are products which have kind of heat exchanger, that is using heat exchangers so that they'll provide a ventilation, at the same time recover the heat from the fresh air from outside, using the stale air from inside, so that it will be cooled down, and the energy requirement will be limited with the ventilation also. So like these are ways by which ventilation can be improved even in rooms where you have air conditioning. And then there are filtration methods, which I'll be discussing further. Controlling the source of pollutants and ventilation are effective ways to improve indoor air. In situations where these are not effective, we will need to look for options for filtration, which can be an effective supplement to source control and ventilation. So using a portable air cleaner, like the different types of air cleaners are one which can be portable, that is which can be moved around the house, and it will clean or filter the air in a single room or area wherever it can be placed, where people are occupying more frequently.
Rati madam?
Sir, அவங்க ஸ்டார்ட் பண்ணல சார்.
Divya madam?
Yeah, sir, am I audible?
Yeah, now audible. I think it has gone out and again connected.
Okay, there was a disruption in between.
Yeah.
Okay, so we
Now
were
you
talking
can,
about
that portable air cleaners.
yeah. So yeah, so HV this portable air cleaners are like basic components which include a filter or other air cleaning technology and a fan that propels air through the filter so that clean air is available to the inhabitants of the building. And portable air cleaners may also have a panel filter with activated carbon filter encased in a frame or other sorbent materials to remove gases, the VOCs that we talked about, and other odorous compounds.
Ma'am, can you
Hello?
share the screen, ma'am?
Okay. Is it visible now?
Yes, ma'am. Okay.
Yeah. Yeah. So in some of the portable air cleaners, beyond the filtration and sorption, further technologies to increase pollutant removal, inactivation or conversion are also used. Then ultraviolet lamps are sometimes used to inactivate the biological contaminants in the space. So that also will be discussed further in coming slides. So in the HVAC system, air cleaners can also be mounted, like duct mounted in HVAC systems. In heating, ventilation, and air conditioning systems, which will be like a central system for a building. So it will be installed in the return ducts of HVAC system, so that the conditioned air passes through the air cleaner, and so the contaminant removed and clean air will be available. This one system would be sufficient to provide clean air to most parts of the building. Now, one parameter which has to be seen very closely in the when we select, or which is specified for an indoor air cleaner, is CADR, that is clean air delivery rate. So it basically defines the rate at which air is being recycled. So the fan speed is what would or the blower speed would basically determine the clean air delivery rate for an air cleaner. So the faster the fan, better would be the clean air delivery rate. But then, of course, the technology that is being used for air cleaning would either limit the flow or would need a lower flow rate. So basically, CADR would be decided by kind of a compromise of both. So CADR is normally specified only for particles, and so yeah, as I told earlier, higher fan speed means higher CADR. Yeah. So, like I've just given a table which is specified in the EPA document, which is the Environment Protection Agency of the US. So in that, they have mentioned the room area and minimum CADR and CFM, cubic feet per minute. And it's approximately 1 CFM would be 1.7 cubic meters per hour to convert it into metric. And room area of 100 square feet would require a minimum CFM of 65. 200 square feet would need 130 and so on. So this kind of standards are applicable for an air cleaner, which to determine what is the CADR required for an air cleaner to be effective for a particular area. So normally these when they have specified such room sizes, the height is assumed as 8 feet. So the height also of the ceiling also need to be considered. And the CFM has to be suitably corrected for a higher, taller building. So going on to the different filtration methods. We have particle filters. So I'm just discussing 3 different types of particle filters, which are fibrous media air filters, which are basically air filters which remove particles by capturing them on fibrous filter materials. Then we have electrostatic cleaners, which depend on the electrostatic precipitation principle, charging and collection of fine particles. And also there are ionizers. So ionizers, basically what they do is they emit ions, which get deposited on particulate matter, and because of the electrostatic force, they get deposited on any indoor surface. So basically it is removed from the air, and the chances of inhalation are eliminated. So this is one method of particle filtration. And then we have this ultraviolet germicidal irradiation, called UVGI. So it is basically designed to reduce the number of viable airborne microorganisms, basically by killing or deactivating them. So that is one technology which was commonly used during the COVID time also. And then there is like sorbent media, which like the commonly used sorbent media is activated carbon filter. So sorbent media, basically what they do is remove gaseous air pollutants by like they get deposited on the media by the process called adsorption, or convert them into harmless byproducts using a combination of physical and chemical process. So basically here the there are no harmful byproducts when using an activated carbon filter or similar adsorbent media. That is one advantage of these filters. So and only sorbent media filters are normally used for gas phase cleaning for gaseous pollutants, and I mean without producing any harmful byproducts. So normally they have a finite capacity for adsorption. So there is a need to replace them regularly. Adsorption process, basically it refers to individual molecules, atoms or ions gathering on surfaces. Like an example would be water vapor getting adsorbed by the silica gel. So these are the filtration methods. We'll discuss further on them. So the fibrous media filter, looking at them closely, the fibrous air filters remove particles by capturing them onto fibrous filter materials. So these media filters vary widely in their ability to remove particles. Their removal efficiency depends on multiple parameters like particle size, velocity, filter thickness, filter porosity, etc. Again, there are two different types of fibrous media filters. One, the material is used as such, and the second variety is where the manufacturer like initially is like he modifies it to have extra like electrostatic charge on them so that the deposition is better. So in general, the fibrous media filters without electrostatic charge tend to increase the efficiency with dust loading over time, because when I mean basically it is a kind of a porous medium through which the air passes and the material gets deposited. So the pores would be smaller, and so the efficiency would increase over time. But it is not so for the media filters which are like electrostatically charged medium, because the charge would die down over a period of time, and hence the efficiency would come down. So the different test metrics which are adopted for measuring the efficiency of or the effectiveness of fibrous media filter are minimum efficiency reporting value called MER, or microparticle performance rating, or filter performance rating. These are different standards adopted by various countries for measuring the effectiveness of the fibrous media filters. Then there are like a kind of fibrous media filter is high efficiency particulate air, or HEPA filter. These offer the highest available particle removal efficiency of fibrous media filters for a wide range of particle sizes. So the you can see in the picture that in such fibrous media filters, they introduce multiple pleats so as to increase the surface area and thus have more effective collection, but not seriously affect the flow. So the deep pleats of a HEPA filter normally helps to be more effective in collecting ultra fine particles with higher efficiency. So different MERV rated filters are shown in the picture. You can see that as the MERV rating goes up, the pleats or the pattern of the filter varies. And of course, the depth also determines the effectiveness. But when you increase the depth, there is an impact on the flow rate. So that will affect your CADR. For fibrous media filters, basically, they have excellent removal capabilities for many particle sizes. We can say they are kind of similar to the bag filters used in thermal power plants or industrial applications for removal of fine particles. Whereas disadvantages are that regular replacement is required, because once a filter gets clogged, you will have to as the load increases, the removal efficiency when it gets deposited with more amount of this one, the pores close down, and then the removal efficiency is reduced, and then at that point of time we need replacement of the filter. Then used particle filters are again because these contaminants get deposited on that, it will be a source of sensory pollution or odors. And also high pressure drops, because the air has to come through the porous media or the fibrous media, so there's a lot of drop in the pressure. So when mounted in HVAC systems and all, they can have a severe negative impact. Then we come to the electrostatic precipitation. In normal, that is electrostatic precipitators, which are used for maybe power plant applications or industrial applications, are a single stage. So they have there's a single stage of energization. So your charging and collection happens in the same space. But what is more suitable for finer particles which are normally found in indoor air, like PM10 and PM2.5, is a two-stage ESP. So here, why it is called two-stage is because there are different portion of the electrostatic precipitator for charging and collection. So there is an ionization region where you have a higher potential power supply used to create the ionization of the air and thus charge the particles. And normally for indoor air cleaners, positive corona is used because it generates less ozone. And the collection, that is the only charging happens in like in the picture we can see a very narrow region for ionization, and then a very broad region for collection. So that is where we have alternate positive and negatively charged plates for these particles which are charged in the ionization region to get collected. And here, basically, the difference between single stage ESP and this is also the laminar flow. So in charging process itself, you have different, two different types of charging called field charging and diffusion charging. So this kind of an arrangement is more suitable for diffusion charging, which is found to be effective for fine particles. So the region, because there are more number of plates, the flow is forced to be in a laminar mode, and that basically helps collection of finer particles. So it is found that the two-stage ESP charges and collects particles as small as sub-micron sizes. So it was the size of COVID-19 virus was found to be like of the range of 0.1 micron to 1 micron. So this technology was would have been effective for the inactivation of such airborne biological contaminants as well. So the advantages and disadvantages of electrostatic precipitation being used for indoor air cleaning. Basically, you can have a high removal efficiency for a wide range of particle sizes, like in the case of fibrous filter. But there is all in the case of fibrous filter, you have a very large pressure drop. Here you have a very low pressure drop, and there is minimal impact on HVAC systems. And low maintenance requirements. So basically, in a fibrous media filter, you will have to remove the filter regularly when it gets clogged. But that is not the case here. Here, the ESP module can be simply removed and water washed to remove the contaminants, and then it can be reused. So that is a major advantage in case of the ESP for indoor air cleaning, the two-stage ESP for indoor air cleaning. And disadvantages are like ozone and other generation of such gases. So you would have to have some kind of a filtration method further to the ESP to reduce such gases. And here the efficiency decreases with the loading, because as there is more and more deposition of particles on the plates, the ESP charging would be affected, and so it'll basically reduce the efficiency. So plates would have to be cleaned at regular intervals. So then we have ionizers, where there are high voltage wire or carbon fiber brush to electrically charge air molecules. So these produce negative ions that attach to airborne particles. So, and subsequently, the charged particles can attach to nearby surfaces, such as walls or furniture. Such cleaners are available as like tabletop portable units, and because ionizers typically do not these ionizers do not typically utilize fans. They just emit the negative ions into the indoor air, and so they typically have very low CADR. The clean air delivery rate would be much less when compared to the other cleaning mechanisms. So for ionizers, you have advantages like the power requirement is low. They are very quiet and low maintenance, because there is no fan. There would not be any possibility of noise. And disadvantages are normally that it generates ozone in the process of charging, and low effectiveness because of the low CADR. And also, since the we say that the charged particles are easier to settle, so there is a possibility that they may settle in the respiratory tract as well. So though the probability would be less, but there is that also is considered as a harmful effect of the of an ionizer. Then we come to the ultraviolet germicidal irradiation, which is used to kill or deactivate microorganisms such as viruses, bacteria, fungal spores, and so on. So the picture shows the range of wavelengths for different UV radiation. So UVA and UVC, 315 to 400 nanometer and 100 to 280 nanometer. This ranges are normally used for normally used for the application of ultraviolet germicidal radiation. So normally they use mercury vapor lamps that emit UVC radiation. Wavelength normally is 254 nanometers. So then the sufficient exposure time and lamp power have to be calculated, and such that the UV light can penetrate the outer structure of the microorganism, and thus it alters its DNA and prevents replication and causes cell death. So coming to the next slide. The lamps used for surface disinfection are normally located like in the air duct of an HVAC system, and so they would be normally kept perpendicular to the airstream for maximum contact of impact on the air which flows through the duct. So here, how do we calculate the UV dose of a certain UV lamp? Basically, in the the data sheet of the UV lamp, they would have specified the intensity. Intensity also varies with the distance. So there would normally be a graph as to against a distance, what would be the UV intensity. So intensity into time is considered as the UV dose, or the quantity which determines how effective the UV lamp is in germicidal radiation. And the standards which normally specify what is the UV dose required for a certain medium are ANSI or ASHRAE standard. ASHRAE is American Society of Heating, Refrigeration and Air Conditioning Engineers. So, and the ANSI standards are there, which specify the amount of the UV dose which is required for different media with the different contaminants. So basically from this relationship we understand that the flow rate, then distance and turbidity of medium, these are all possible factors which determine the effectiveness of the UV, the distance from the lamp, etc. So the dose has to be suitably calculated considering all these factors, correcting for all these factors. Also the end of life of the lamp would be specified. So that is where it is expected to reach 80% of its initial UV output. So this lamp life also is a factor which must be considered in calculating the intensity. So considering all these factors, suitable UV dose has to be decided, and the UV lamp has to be chosen for different applications. So excuse me. The advantages of the UV lamps being used for germicidal irradiation are they can be the intensity and sufficient contact time has to be decided suitably. Otherwise, it will not be of a desired effect. And the disadvantages include the uncoated lamps again can generate ozone. There's potential for eye injury, so it has to be properly insulated. Optical insulation must be there so that it is not harmful to the user. Then the effectiveness increases with lamp intensity. Normally in residential UV air cleaners, these would be kept relatively low considering the ill effects of UV. And though the ultraviolet inactivates the microbes, they would still be airborne. So you have a risk of inhalation. So it is a good practice to have some kind of a filtration method to remove these particles after the ultraviolet lamp. Then we have the sorbent media. And the most commonly used sorbent media is activated carbon. It removes gaseous contaminants. So it has a potential to remove most hydrocarbons, aldehydes, organic acids through adsorption, and ozone through chemisorption. By chemisorption, you mean absorption by converting it to through chemical processes. There is a chemical reaction which happens when ozone comes into contact with the activated carbon, and thus it gets absorbed. These are some of the advantages and disadvantages of using sorbent media. Sorbent media have the potential to for high removal efficiency of many gaseous pollutants, and there is no byproduct formation. So that is a major advantage. And in disadvantages, regular replacement is required because absorption capacity gets exhausted easily. Then there is high pressure drop again, just like our fibrous media filters. Because the adsorption and chemisorption process are dependent on the nature of the gases. Different media have different efficiency for different gases. So you cannot have a common media for all the gaseous pollutants. So that is one of the disadvantages. Coming to an indoor air cleaner implementation, like just a sample air cleaner implementation considering the various factors. We have we can have a two-stage ESP in the upfront of an air cleaner. So which has a baffle plate as a pre-filter, and then the air passes through the ionization area and then to the collection plate. So this two-stage ESP basically would collect all the PM10, PM2.5 particles and some of the biological contaminants as well, depending on their size. And then you have we can have a UV lamp which will inactivate the virus, bacteria, and all other pathogens, and an activated carbon filter for removing, because the two-stage ESP as well as UV will produce ozone, and then there are other organic compounds, VOCs, which could be present in the indoor air. And so using this activated carbon filter, those VOCs will be filtered out and we'll get clean air. So that's all with my presentation. Thank you for patient listening. Any clarifications, please?
Good evening, madam. I have clarification. See, in your slide in air cleaner, you have shown the arrangement of collector in the horizontal direction. I think it should be in the vertical direction.
Can you be louder, sir? Your voice is.
In the slide for air cleaner, that is third slide also, arrangement of collector has been shown in the horizontal direction. See, in the ESP last before slide, you have shown it correctly. But in that slide, the collector is in horizontal direction, along the airflow in the horizontal direction. Just for your information, whether it is correct or not, you can check out.
The collection plate is along the flow, sir.
No,
I mean, basically,
correct,
this is a like
collective
plain
plates is along the flow.
plan view.
Plan view, but if it is plan view, I don't know. You can just check up. It should be in the vertical direction, in my opinion. Plan view, the flow, you cannot see. Okay, you have shown it in plan view.
Yes.
Okay.
So the indoor, I mean, the air, the plates are kept in the direction of the flow, so that when they pass the electric field, they will get, I mean, because they're already charged in the ionization region, they get collected in the collection area.
Okay, if it is you have shown it in the plan view, it is okay, but normally the dissipation should be as you have dissipated in the last before slide. Just check up because it gives a. I am having little knowledge on ESP, so
yes, sir.
It gives a different meaning. That's why
yes, sir. Yes, sir. Yeah, probably this depicts it more.
Yeah, that should be in the horizontal. Because then only the collection, and then we hammer it and then collect it and go to air handling system.
Yes, sir. Yes.
Okay.
Any other question from participants?
Yeah, I'm Suresh Kumar. I have a question.
Okay, sir.
Yes, sir.
How do we know that room is having pollutants? Your living room is having pollutants, which is more than the limit. Any instrument is up?
Yes, so there are tests for measuring the concentration of particulate matter as well as the ozone and other contaminants, and standards which define their like the limits for each of them. You like using those tests, it can be like measured and identified, sir.
For ambient condition, probably a lot of agencies. But in for the domestic application, any instrument is available in market which can tell that maybe it can say this much is so or above limit to green, red, something like that. No. If you come across, you can let us know.
Yes, sir. Actually, no, we'll have to depend on I think labs which do such testing for clean room environment and to estimate this one. I have not come across any instrument that is commonly like available for these kind of tests.
Okay, thank you.
Hello.
Hello.
This is SS Mani.
Yes, sir.
Hello.
Yes,
sorry,
sir, yes,
I
sir.
joined late. One question only: whether two-stage preservation anywhere implemented in, in pilot scale in any plant?
No, sir. This is basically for indoor air cleaning
Application
application.
only.
We had done a study for implementation of two-stage for indoor air cleaning application. So we had found that the PM10 and 2.5 concentrations are significantly coming down using these.
Definitely.
Yes.
Anyway, thank you very much for the nice presentation. But I joined late. Sorry for that.
Yes,
But
sir.
of course, myself, Mr. Suresh Kumar, we made a presentation for controlling Delhi pollution also with the same kind of technology only.
Yes, sir.
Long back, I think before my retirement.
Yes, sir. Yes, sir. You have projected. Right now, sir, what they've done is, sir, they went ahead, corporate R&D and Haridwar. They've installed one pollution control tower in Noida campus. But it worked for only few months. They had some problem of choking. Now they've stopped it. But they have not implemented two stages. Instead, they went for a fabric filter. They were getting a lot of choking issue, and again they are trying to do different options.
But this can also be tried.
This is what they were actually coming back to us, but we said it has to be first tested at outdoor condition. Then after that they didn't come. This very one, Ranipet, we have made one for a room size. We have tested with third-party agencies also.
Very good.
Works very well. It works well.
Yeah. Excellent. Thank you. Thank you. Thank you. Congrats. All the best, Divya.
Thank you, sir. Thank you.
Thank you.
Probably this two-stage ESP can be a product for Ranipet in future for room applications.
It is for the outdoor ambient also, like Delhi pollutants. This could be the suitable product. Yes, apart from
for indoor also we had proposed, but of course viability is a problem because this is more of a commercial product rather than.
Plus, it involves providing some higher voltages to the collecting electrode and emitting. So the safety concern, all that also we have to see. But this is very more reliable product compared to HEPA filter products.
Actually, in our olden days, we did not even think of buying drinking water in bottles. Now it is happening. Similarly, it will also be happening in the future. That is what my gut feeling says.
And what the prediction is that when the drones and other things started coming in a larger way, the particulate matter pollution is going to increase multifolded because people start using these drones and there will not be any control on that. So that case, your home must be fully protected. Probably nobody will be having windows in future in the home. So something like that. So for that case, we should have this kind of products in every home, like having a fan in every room.
No, window will be there. Window will be there, but window will be having a filtration like ESP or fabric filter like that. You cannot live without a window. Thank you.
Yeah, probably we don't know, but maybe they can install one camera outside and then show outer view also to the window.
That's possible. All the windows we can fix some filter.
Yes.
And give pressurized outside
probably
some pressure.
Any
so
option,
the air
but
will be coming in.
Multiple options could be done.
Thank you, sir. Thank you, madam, for your continuous effort. And I think I have made with your illness also, I have made you to present this today. It had went well. Formal vote of thanks will be given by our secretary, Shri Vivek.
Yes, sir.
Shri Vivek.
Yes. Good evening, one and all. On behalf of Ranipet Local Center, I'd like to thank Mrs. Divya for accepting our invitation and delivering a very good presentation in such a short notice. We are enlightened by the key takeaways from the session, namely need for indoor air quality, particulate matter, and other indoor air pollutants ways to improve indoor air quality and its implementation. Also, I would like to thank Chairman RLC for his efforts in arranging this program. I thank Tamil Nadu State Center for enabling this webinar session through Zoom platform. Last but not least, I'd like to thank all the participants for their active involvement, passionate listening, and observation throughout the session. Once again, thanking you one and all.
Thank you. Thank you for the opportunity also.
Thank you.
Thank you. Thank you, Vivek.
Thank
you, sir. Rati madam, close பண்ணிக்கங்க.